Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 10th, 2025, about 6 days ago. It introduces a reinforcement learning-based system called RouteRAG that lets a large language model decide, step by step, whether to keep reasoning, search text, search a knowledge graph, or answer. And this adaptive control gives both higher accuracy and lower retrieval cost than previous retrieval augmented generation setups. The paper is titled RouteRAG, Efficient Retrieval Augmented Generation from Text and Graph via Reinforcement Learning. And as we will see later, the implications for complex question answering are quite significant. So the introduction just described the high-level idea of adaptive retrieval, and Algorithm 1 now spells out the concrete loop that makes this work. Algorithm 1 shows the policy starting from an empty response, then repeatedly generating tokens in small rollouts until it hits a special control token. When a search token appears, the algorithm parses the subquery and selects a passage, graph, or hybrid mode based on the mode tokens. The retriever then returns documents, which the algorithm wraps as information and appends back into the context so the model can keep reasoning. If an answer token appears instead, the algorithm stops and returns the accumulated response. So Algorithm 1 described the token-level control loop, and Figure 1 now contrasts how the overall training setup changes. The left panel illustrates older multi-turn retrieval augmented generation, which always retrieves passages and only rewards whether the final answer is correct. The right panels show RouteRAG inserting a retrieval mode selection step, so the policy chooses passage, graph, or hybrid retrieval during reasoning. The bottom right workflow then adds a second training stage that factors in retrieval time, so correct but slower trajectories receive smaller rewards. So Figure 1 contrasted the training schemes, and Table 1 now shows how that translates into question answering scores. The top block with the GPT-4o mini backbone shows strong graph-based systems, but their best average exact match and F1 still leave room. The middle and bottom blocks reveal that RouteRAG 3b and RouteRAG 7b reach the highest averages for their backbones, especially on multi-hop datasets, which means smarter routing lets much smaller models rival or beat graph systems powered by GPT-4o mini. Alright, Table 2 digs into why the policy matters so much. The top block compares full training to removing Stage 2, or all reinforcement learning, and the scores show that Stage 1 alone already boosts accuracy a lot, while Stage 2 gives another clear bump, especially on multi-hop sets like Hotpot QA and 2Wiki. The lower block compares using only passage, only graph, or only hybrid retrieval, and the dynamic mix still wins on average, which means adaptive routing really is better than any fixed retrieval strategy. So Table 2 highlighted how multi-stage reinforcement learning and adaptive retrieval each boost accuracy. And Table 3 now isolates the impact of the efficiency reward. The table shows that adding this reward slightly raises average exact match and F1 scores for both RouteRAG 3b and RouteRAG 7b. The gains are modest but consistent across datasets, which means the model retrieves less while still matching or improving answer quality. In other words, the efficiency term does not trade accuracy for speed, it actually nudges the policy towards smarter evidence use. So Table 3 suggested that efficiency rewards preserve accuracy, and Figure 2 turns that into retrieval behavior. The overall figure shows that adding the efficiency reward consistently lowers the average number of retrieval turns across all datasets. The left panel with RouteRAG 3b shows modest but steady savings. The right panel with RouteRAG 7b shows much larger reductions, which means the bigger model learns to skip many unnecessary searches. While Figure 3 shifts from retrieval behavior to the depth of reasoning itself. The radar charts compare average reasoning steps for the base QN 2.5 models versus the trained RouteRAG versions across all 5 datasets. The left chart for 3B models shows RouteRAG consistently taking more reasoning steps, especially on MuSiQuay and 2Wiki. The right chart for 7B models amplifies this pattern, with even larger increases in reasoning depth on the harder multi-hop datasets while still adding steps on PopQA and natural questions. RouteRAG shows that a single reinforcement learning trained policy can smartly route between text and graph retrieval, taking more reasoning steps while using fewer, better targeted searches. The broader implication is that retrieval augmented generation can become both cheaper and more capable for complex question answering. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.